The next great gold rush, it's not going to be in some forgotten jungle or frozen wasteland. It's happening right now, literally, right above our heads. Today, we're diving into the incredible trillion-dollar race to unlock the riches of space itself.
And let's just start with this quote, because it changes everything. The first trillionaire won't be made on Earth. That's not just a clever line. It's the whole mission statement for an industry that is about to completely redefine wealth, resources, and really, humanity's future in the cosmos.
And this right here really gets to the heart of it. For all of human history, our entire economy has been a closed loop. We've been stuck on one planet with a finite amount of stuff, and we've even fought wars over it. What we're talking about now is blowing that system wide open into a frontier of almost unbelievable abundance.
Okay, so what is this treasure we're actually looking for? Because not all space rocks are created equal, right? Knowing the difference, that is step one in this whole cosmic gold rush.
Think of this as the treasure map. You can basically break down the targets into three main types. First, you've got your C-types. We call them space gold, but not because of metal, because of water. See, in space, water is rocket fuel. These things are basically the gas stations of the solar system. Then you have S-types, the building blocks. These are floating quarries of iron and silicates, perfect for building stuff in space. And then you get to the M-types. This, my friends, is the payday. Asteroids just packed with precious metals like platinum that could literally turn global markets upside down.
So we know what we're looking for, but how in the world do you actually catch a rock that's hurtling through the vacuum of space? This is where we get into some of the most mind-bending engineering challenges you can imagine. Any mining mission, no matter how ridiculously complex it is, really just boils down to three huge challenges. First, propulsion. You got to get there. Second, you have to anchor. You need to somehow latch onto a spinning rock in zero gravity. And finally, extraction. You actually have to get the goods.
And that anchoring piece, it's a massive puzzle. You can't just land on an asteroid. It has pretty much zero gravity. If you tried to drill into it, you'd just push your whole spaceship away into the void. It's why engineers are coming up with these brilliant solutions, like harpoons or grippers with thousands of tiny little hooks that work like a gecko's foot, and even giant magnets for those metal-rich M-types.
But hey, forget drills and shovels for a second. The most futuristic idea out there is something called optical mining. I want you to picture this: giant, foldable mirrors that focus sunlight into a single, incredibly intense beam. It gets so hot, it literally vaporizes the surface of the rock, and then you just collect the valuable materials as they float away. It's like using a cosmic magnifying glass to crack open a safe. So let's say we actually solve all this insane engineering. What happens next? Well, this is where the technical challenge explodes into a full-blown economic revolution. We're talking about forging a completely new economy in space, and the ripple effects of introducing practically infinite resources are staggering. To really get a sense of the scale here, just look at this number, $2 trillion. That's the estimated value of a single half-kilometer metallic asteroid. We're talking about one rock that could hold more platinum than has ever been mined in the entire history of humanity. Which, of course, leads to the big, scary question. This isn't just about getting rich. What actually happens to our global economy when $1 trillion worth of a precious metal suddenly isn't so precious anymore? Well, it's really a two-sided coin. On one side, you've got the shock. The price of something like platinum would absolutely plummet, and that could wreck entire industries here on Earth. But then you have the opportunity. With those same materials suddenly becoming cheap and abundant, we could kickstart a revolution in green energy and electronics. When scarcity disappears, innovation just explodes. And this brings us to maybe the most important point of all. The first trillionaire probably won't get rich just by selling platinum back on Earth. The real fortune, the truly massive wealth, is in owning the infrastructure. Think back to the gold rush. The biggest winners weren't the guys panning for gold. They were the ones who sold the shovels and owned the railroads. In space, that means controlling the refueling stations and the shipyards in orbit. But, as we push into this new frontier, our technology is moving way, way faster than our laws. It's the Wild West all over again, which brings up a critical question. Who actually owns the sky?
The legal side of this is just fascinating. The big one, the 1967 Outer Space Treaty, says pretty clearly that no nation can claim ownership of the moon or an asteroid. But there's a loophole, a big one, pushed by the US, and it basically says this. Okay, you can't plant a flag and own the rock itself, but any resources you manage to dig out of it, those are yours. It's basically finders keepers for the cosmos.
And a loophole like that, well, it creates some pretty serious risks. You've got the very real possibility of corporate claim jumping. I mean, what happens when two companies get to the same asteroid at the same time? And then there's the absolutely critical issue of planetary protection. The engineering has to be perfect, because the last thing anyone wants is to accidentally nudge a multi-billion-dollar asset onto a collision course with Earth.
So, when you step back from it all, where is this actually headed? Ultimately, this is about the evolution of our entire species. Right now, you could say we're a Type 0 civilization, totally dependent on the resources of our home planet.
But the goal, the real prize, is to become a Type 1 civilization, one that can actually harness the potential of its entire star system. Asteroid mining isn't just about money. It is the first, crucial step on the ladder to becoming a truly spacefaring species. The era of just digging things up from our own planet is ending. We've nearly tapped out our cradle. So, as we look up at the night sky, what are we really seeing? Are those just cold, distant lights? Or are we looking at the fuel, the steel, and the gold of our shared future?